Welcome back. This is Nick Agram. Domain and range. Definition: the domain of a relation is the set of values of x in the relation. So we go first with the domain. So for this example that I have here, the domain, I will put it D. I will write it this domain. Lazy. Okay, let's see. All x, values of x in the relation. Okay, as you can see here, if I will continue here, all the x is included, so I will have all values of x. Or I can use this one, x, such that all set of x, all values of x, such that x is an element of a real number. You can use that way. Okay, let's see here the domain for this. As you can see here, it is very near from this one. This line is very important. Our x here, very near x is equal to 2, but it is not equal to 2. It doesn't touch. X is equal to 2. So that means all x, but x should not be equal to 2. Okay, the next one here, the domain here is, as you can see, from -1 here, from -1 to infinity. So we have sets of all x such that x is greater than or equal to, because this one is solid. If it's not solid, then it is not included. -1. Okay, and then we have range. Okay, the range of a relation is the set of values of y in the relation. I should say allowed. Is a set of allowed values of y. Okay, let's say range. So the y is from 1 here, as you can see here, 1. So the set of y such that y is less than or equal to 1. How about here? As you can see here, I can use this notation also here, sorry. And here, y such that y is not equal to 1. It touches y is equal to, it's very near y is equal to 1, but it doesn't touch y is equal to 1. So that is your limitation. Okay, and here we have y such that you have -3 here and up. So have y is greater than or equal to -3. Let's continue. For each of the following graphs, state the domain and range. We will start with the domain. As you can see here, from 8, our x is 8, to the -infinity. So that means the values of x such that x is less than or equal to 8. How about here? The values of x such that, as you can see here, it goes that way and it goes that way into infinity. Then we have x is an element of a real number, or all values of x. You can also write that way. Okay, then now it is the range. Then we have y, the values of y, such that the lowest is -2 and it goes up to infinity. and we have y is greater than or equal to -2, and here we have the lowest is -1 here. So we have y such that y is greater than or equal to -1. Let's try another example without the graph now. State the domain and range of each of the following functions. If you have a graphing calculator, then you can use that and you can see the range and the domain and the range. But if you don't have, then you need to see, you have to put a value of x, and you can see if it allows or not. So we have the domain. Okay, if I'm going to put a value of this of x such that it allows me, then it should be positive. So that means x minus 5 should be greater than or equal to 0. Always, because I don't have, if I have negative here, then it should be error. It should be, what's this? Imaginary number, complex number. No, imaginary number. Okay? So that means x should be greater than or equal to 5. So our domain is all x such that x is greater than or equal to 5. Our domain in B, as you can see here, x minus 5 should not be equal to 0. So that means I can have all the values of x except when x is not equal to, so that means x minus 5 is equal to 0. So x should not be equal to 5. So my range here is all the values of x such that x should not be equal to 5. Because when that happens, then I have the denominator equal to 0, then it is not acceptable. Okay. Here also, I should have here, aside from x minus 5 should not be equal to 0, aside from that, x minus 5 should not be less than 0 either. So I have 2. So this means that I have my range now, x such that x should be greater than 5. Yeah, greater than 5. Not equal to 5, because if I have equal to 5, then I get 0 here. Then it is not allowed. Okay? Now it is the range. Let's see. The range, as you can see here, if my x is equal to 5, we said that it is equal to 5, then I have, it should be x is greater than or equal to 5. So when x is equal to 5, then I have 0. So it should be, my range now is y. The smallest should be such that y is greater than or equal to 0. Not more than that. Okay? Not less than 0. Okay, here. Let's see. We can have negative here for x. Then we can have, what's this? We can have positive number here, big negative numbers, or small negative numbers. It's alright as long as x is not equal to 5. So when it is very big, it is almost 0. Okay, when this is now very big number, and then it is almost 0, but it is not 0. Okay, when it is a negative number, it's the same. It's almost 0, but it's not 0. So our range here now is y such that y is not equal to 0. Never be 0. Okay, here now though, if this is a very big number now, we cannot have greater than 5, for example. Very, very big number. And it is very near 0, but it is not 0. Then we have y such that y is greater than 0. The difference between these two and these two is that I can have negative numbers in B. I can have negative value of x in B, but I cannot have negative numbers or negative value of x in C. That's the difference. Okay, I hope you understand. Domain and range is one of the most difficult concept that my students understand because it's very abstract, and I hope you understand. And I hope you learned something, and on my next video I will be discussing composite functions, even more abstract, and I hope you can watch my next video also. And I am going to say again, thank you for watching, and I hope you learned something. If you like what I am doing, please subscribe. Have a nice day.